Hi everyone. In today's video, I'll be explaining how to understand how to read a graphic, and I'll be showing you with a few examples. So first, plot the following exponential function. Function of x is equal to 5 times 2 to the power of 2x minus 4 minus 10. So to really get an understanding of the graphic, we're going to first have to recall a few notions. Recall exponential growth, which is a pattern of data that shows sharper increases, and we call exponential decay, which means that the rate of decrease becomes smaller as the quantity itself gets smaller. A few approaches might be find the domain, the range, the transformations, the asymptote, and some key points of the function. Now to determine the first domain and range, take this function of x is equal to b to the power of x. The domain here is the set of all real numbers R. So from negative infinite to positive infinite, as x can be any number you can think of. The range, however, goes from 0 to positive infinite because no matter what number x is, the function of x has to be positive. Now here, identify the base. Because the given function of x is equal to ab to the power of x minus h plus k, we get that b is the base, as b has to be bigger than 0 and not equal to 1. If b is bigger than 1, then the curve is increasing from left to right. If b is in between 0 and 1, then the curve is decreasing from left to right. Now step 3 here is to determine the transformations. So first, h in this function means the horizontal shift, so from left to right, as it changes directly the value of the exponent and is related to x. Now k here changes the vertical shift. So it doesn't change the shape of the function, but it changes the vertical aspect. Now the vertical stretch and compression is decided by a. When a is bigger than 0, there's a vertical stretch. When a is in between 0 and 1, there's a vertical shrink. And when a is smaller than 0, there's a reflection over the x-axis because now the whole function is now negative. And the reflections are caused by, first, when a is negative, so here negative 1, and because of that, it's a reflection of b to the power of x over the x-axis. Now it's negative b to the power of x. Now here, when you have a negative over the x, it does the same effect but over the y-axis because now you change the value of the x and you flip it over. So step 4 is going to be to find the asymptote. And given this function, the horizontal asymptote is going to be function of x is equal to k, because the asymptote is a line that the function cannot cross, and it can't cross because a number to the power of a number can't be equal to 0. So if you assume this is 0, we can find the asymptote. Now there is no vertical asymptote for an exponential function because the exponent can be anything ranging from negative infinite to positive infinite. So there's no limit to x. Step 5 here is going to be to calculate the interceptions at the x and y axis. So given the exponential function of x is equal to b to the power of x, all functions have an y-intercept of 0, 1. Because when x is 0, y necessarily has to be 1. But there is no x-intercept for this basic exponential function, as the x-axis is the asymptote, and no function of x can be equal to 0. So now step 6 is to calculate the other key points to draw a better graphic. So we're going to have to select a few x values, and then we're going to draw them in a graph. And for example, when x minus h is equal to 0, then y is equal to a plus k. When x minus h is going to be 1, y is going to be a b to the power of 1 plus k. When x is 2, and so on. Now step 8 for this graph is going to be a summary of the key features of this function. So the domain here are all the possible values for x ranging from negative infinite to positive infinite. The range is going to be all the possible values for y, which is going to be ranging from negative 10, not included, to infinite. Not included because this can't be equal to 0. The shifts are going to be 2 units to the right and 10 units downwards because this exponent can also be written as 2 times in brackets x minus 2, and that x minus 2 can also means 2 units to the right. It's 10 units downwards because there's a minus 10 here. Now the asymptote is going to be function of x is equal to minus 10 because the asymptote is a line that the graphic cannot cross, and it can't cross if this is equal to 0 because this can't be equal to 0. There is no vertical asymptote because x can be equal to anything. The intercept here, the y-intercept is going to be the coordinate 0, negative 9.7, because when x is 0, y equals 5 times 2 to the power of negative 4 minus 10, which is negative 9.7. Now the key points are going to be uh, this, because when the exponent is equal to 0, you can calculate that x is equal to 2 and y is equal to negative 5. When the exponent is equal to 2, x is equal to 3 and y is equal to 10. So we chose those numbers because they're easy to calculate and they're integers. So because of the function, we can also try to find a few other values, and with those we can really try to draw a really precise graphic. And this is what the exponential graphic looks like. Now try this question. Plot the following exponential function. Function of x is equal to 5 times 2 to the power of minus 2x plus 4 minus 10. Now a hint for this question is, as said before, when the x here is negative, there's a reflection over the y-axis. Now try this. Plot the following exponential function. Minus 5 times 2 to the power of 2x minus 4 minus 10. So a hint to better visualize the previous graphic would be to first understand this rule, which means when a is negative and a is positive, both graphics reflect over the x-axis. So now here a is minus 1 and here a is 1, and both reflect over the x-axis. So it'd be the same thing for the original and the one in the previous slide. Now thank you very much for watching, and if you have a few questions or if there's some imprecise parts, don't forget to ask them down below. See you next time.